Thanks, Connie. Now that we know what pilots have to keep in their minds with today's aircraft, let's consider the future of flight. Have you ever wondered what the airplanes of tomorrow will look like? Or how fast they will travel? Will tomorrow's planes travel into space or beyond? On today's show, we're going to learn how NASA researchers and engineers are using geometry and algebra to design, develop, and test future experimental airplanes.
What is an experimental plane?
Experimental planes, or X-planes, are tools of exploration that come in many shapes and sizes. They fly with jet engines, rocket engines, or with no engines at all. Which means NASA flies not only the fastest airplanes, but the slowest as well. Some planes are too small for a pilot, and some are as large as an airliner. The research conducted on experimental aircraft today gives us a glimpse into the future. NASA's developing one of the fastest experimental X-planes ever. It's called the HyperX.
What is the HyperX?
The HyperX research vehicle is an experimental plane that uses this really cool engine technology called the Scram jet.
Go for main engine.
Unlike rockets, such as the space shuttle main engines, which must carry both fuel and oxygen, the Scram jet will only carry hydrogen fuel. It will take in oxygen out of the thin upper atmosphere as it travels along. We call this kind of engine an air breather, and it will allow the HyperX to fly at incredible speeds. In fact, the HyperX will fly at about 3,020 meters per second, which is about 6,750 miles per hour, or Mach 10.
What does Mach number mean?
Mach number represents how many times the speed of sound a vehicle is traveling. For example, Mach 1 equals the speed of sound, which is approximately 302 meters per second, or 675 miles per hour, at an altitude of 100,000 feet, which is the test altitude for the HyperX. Mach 2, which is twice the speed of sound, would approximately be 604 meters per second, or 1,350 miles per hour, at an altitude of 100,000 feet. Mach number are used by NASA researchers to describe the speed at which a plane is flying. Let's use algebra to show how to calculate the Mach number of the HyperX, flying at 3,020 meters per second, or 6,750 miles per hour. This algebraic equation shows that the Mach number equals the speed of the plane divided by the speed of the sound in the air, where m is the Mach number. V is equal to the speed of the plane, and a is equal to the speed of sound in the air. If the speed of the plane is 3,020 meters per second, and the speed of sound at 100,000 feet is 302 meters per second, then what is the Mach number? That's right. 3,020 meters per second is about Mach 10, or 10 times the speed of sound. We'll learn more about Mach numbers later in the show. But first, let me tell you about the HyperX. The HyperX is designed as a flying engine, which means the airplane and the engine are one unit. The unique shape of the airplane develops the lift necessary to keep the plane up in the air, so it doesn't need wings to produce lift. The entire undersurface of the airplane is designed to act as part of the engine. In order to test the scramjet engine, the HyperX is launched by NASA's B-52 and boosted by a rocket to its testing altitude. It will then separate from the rocket, and the scramjet engine begin its test flight.